The aim of this quick review is to understand the mosaic attenuation. The differential diagnosis is not in the scope of this presentation. By definition, the mosaic attenuation is presence of variable attenuation of lung, render the appearance heterogeneous lung attenuation. Both vascular disease and airway disease by different pathways will lead to the same mosaic perfusion or attenuation pattern. In vascular disease, there will be stenosis or occlusion of the vessels. This will lead to oligemia. In airway disease, there will be stenosis or obstruction of the bronchioles, leading to hypoxia, leading to reflex vasoconstriction. At the end, it will give the mosaic attenuation as well. How to differentiate between airway disease and vascular disease? First of all, forget about this false belief about the attenuation of the vessels, that it is specific for the vascular disease. No, I want to clarify that attenuation of the vessels in the low density areas. Here we have example of airway disease. This example for the vascular disease. Both will have attenuated vessels. So how we differentiate between them? By two things. First thing, that if you recognize it on the inspiratory scan, that the low density areas are lobular in appearance. So you can, in this case, you don't need the expiratory scan. But if you are still confused to differentiate between lobular pattern of the low density areas, and you cannot discriminate them clearly from the geographic appearance, non-lobular look of the low density areas, as here in this vascular disease. So in this case, you will ask for the expiratory scan, and in expiratory scan, there will be air trapping in case of it is airway disease. But if it is vascular disease, there will be no air trapping. The expiratory scan rule is to differentiate between the mosaic attenuation if it is associated with air trapping or not. The proper expiratory scan, you will see the trachea in expiratory scan as a circle or a round shape. In the expiratory scan, it will take the D-shaped due to the bowing of the posterior tracheal aspect. In case of airway disease like bronchial asthma with acute exacerbation, here there is variable attenuation with mosaic pattern. In expiratory scan, there is bowing of the posterior aspect of the trachea. So this is proper expiratory scan done. And there's attenuation of the difference between the normal lung and the air-trapped region of the lung. This is the rule of expiratory scan. Increase the difference between the mosaic attenuated area and the normal lung. If this happens, this means there is air trapping, because the normal lung will deflate and will increase the density within. The air-trapped area will be more black or will stay the same density. So there will be increased discrepancy between the normal lung and the air-trapped area. Here, another example of constrictive bronchiolitis. Here, there is mosaic attenuation in the inspiratory scan. This is expiratory scan with attenuation of the difference between the normal lung and the air trapping. Increased discrepancy between the air-trapped areas and the normal lung. In hypersensitivity pneumonitis, here, again, there's attenuation of the difference between the normal lung due to increased density of the normal lung and the air-trapped regions stay the same low density. But in case of vascular disease, you will see the lobular appearance here. There is dilated pulmonary artery, and this is one of the reasons of this mosaic attenuation of the lung parenchyma. And here the pattern are not lobular. Here again, in this chronic thromboembolism, there is a geographic distribution of the low density areas and presence of the peripheral lung scarring. This is diagnostic for chronic thromboembolism. Someone can ask how I differentiate between the mosaic attenuation, and if not, the abnormality or the pathology is just GGO, ground glass density. There is a way to differentiate between them. In case of the mosaic attenuation, there is sharp demarcation between the normal lung and the low density areas. And there is poor attenuation difference between them. And the vessels are attenuated. But in case of ground glass opacities, there is ill-defined borders of the ground glass areas, great attenuation difference between the normal lung and the ground glass areas, and the vessels are normal within both the normal lung and the ground glass areas. What about mosaic attenuation appearing only on expiratory scan? In normal inspiratory scan, this can happen in 40 to 50%, and it's accepted to find mosaic attenuation within one segment or 3 or less lobules, and very scanty, very little, not significant. As here in case of healthy subject, showing only 2 lobules of air trapping in case of expiratory scan. With normal inspiratory scan, this is in normal individual. But if they are significant and appearing as significant air trapping within the expiratory scan, so there is underlying pathology, as here in the chronic bronchial asthma. And here there is multifocal air trapping on expiratory scan, although the inspiratory scan was normal. And by further investigations, this proved to be sarcoidosis. And that's it. Thank you.